This is going to be the second part to PS5. So I'm going to put PS5 up in my top corner of my page again so I can remember that all this information goes with standard number 5. And the first thing we're going to talk about is we're going to carry over with the first page talking about the law of conservation of matter, that matter is neither created nor destroyed. And we usually represent that in a chemical equation. And we have to balance chemical equations because we need to show that the atoms we begin with are the atoms we end with. So we're going to put chemical equations, and then I'm going to surround this in, I'm just kind of be a little decorative here. You don't have to be as decorative, but it kind of adds a little bit of title to this. So when we talked about the chemical equations, there are actually certain parts to an equation. So let's write out an equation. I'm going to say H2O plus O yields H2O2. Alright, so let's talk about the parts of this equation. We have on the left side the reactants. Okay? And these are always on the left. Okay? On the right side, we have the products. And these are always on the right. Okay. Right here, you have the yield sign. Okay? And we say yield. And that means that you have a change in the subject, that energy's been added. Now we have a couple of other components we just want to highlight here. This right here is called a chemical formula. So this is the chemical formula. We have another chemical formula over here with H2O. That's a compound. We know that O and H are elements. The number 2, right down here, we call this a subscript. When we're balancing equations, we use a coefficient. And that's the number that's put in front of that tells you how many of the molecules you have. So we're going to name this, the 1 is understood to be there, and as well as the 1 is understood to be here. But we're going to go ahead and just mark this as our coefficient. Okay? So right under that, we're going to talk about the forms of energy. When bonds are formed or bonds are broken, energy can be either absorbed or released. So we're going to remind ourselves that endothermic we're going to make our arrows go endo, which means they're going in, the energy is going in to the matter. So endothermic, the energy is going into, the object feels cold to the touch, and it absorbs energy. Okay? Exothermic, exo, thermic means heat. Okay? And this is when energy is released. And obviously I use red on purpose because this feels hot. Okay? Feels hot. So the next type of energy I want to discuss is going to take the second half of your page, and this is going to be nuclear energy. So I'm just going to clear this page out, and we're going to talk about nuclear energy. I know your hands are tired from writing 2 pages, but just remember I'm doing the same thing right here. So I'm doing the same amount of writing as you are. And I'm going to do a big mushroom cloud to represent my nuclear energy. Alright, so let's talk about nuclear energy. There's some good things and there's some bad things. So there's some happy things about nuclear energy. Some happy things. And there's some bad things about nuclear energy. Take care of this Camtasia right here that's jumping around trying to tell me that it's done. So I've got some sad things. We'll make him blue. Alright, so what are the great things? The pluses, the good stuff. Nuclear energy creates a lot of energy. Okay? And it takes very little matter to do it. So you don't need a lot of stuff. Sad things, bad things about it, is that it creates a large amount of radioactive waste. So when we do nuclear fission here on Earth, if we did nuclear fusion, we wouldn't have this radioactive waste. But since we do nuclear fission on Earth, we are creating a large amount of radioactive waste. Next thing, that waste that we create remains radioactive for thousands of years. So our great-grandchildren are going to be babysitting the waste that we make today in lead containment units buried underground unless we can find some other means to use it. So radioactive for thousands of years. Another thing is that this waste, if it were to leak and get in our groundwater or escape, or we were to have a nuclear meltdown and things would escape, this waste makes people sick. Causes our cells to do really weird things and can give people cancer. So that's not a good thing. Makes us sad. Okay, so we're going to compare and contrast the 2 types of nuclear energy. So I'm going to make my words first and then draw my bubbles. So let's talk about fission versus fusion. I think I can make these big enough that I can write in them. Let's see. Let's kind of cheat here. Oops. You guys are learning as I'm learning with this stuff here. There we go. Fission versus fusion. I'm going to make this, see if I can make this other one bigger. Doesn't let me move it once it's made it, so I'm just going to go back and draw it by hand. Ha! Sometimes it's not always easier. Okay, fission versus fusion. Okay, so we know what they have in common is that it affects the nucleus and it creates energy. So it has to do with the nucleus. And we know that it creates energy. That's what they have in common. So when we talk about fusion, it fuses atoms. It has very little waste, non-radioactive waste. The sun is created from nuclear fusion, where hydrogen atoms are fused together to make non-radioactive helium. And it happens on the sun. Okay. Fission splits atoms. Remember, your soda fizzes, and so those bubbles pop in your face because they're splitting. So it splits atoms. And that S closer to splits. And it creates radioactive waste. And it happens on Earth. We do it on Earth. It doesn't naturally happen. We force it. Okay? And that's all you have for the second page of PS5.